We're going to take a look at finding the exact values from a unit circle again. We're going to pick some values though that are less common seen. Let's not forget, we can mark this down if you don't have it somewhere handy. Remember, our cosine values are the x value, and our sine value is the y value. And anytime we have a tangent, tangent is equal to the sine value, which is the y value, divided by the cosine value. So we've got these things as we move through here. We've got a unit circle over here to help us if we need it, but let's just take a look and see what we have. First off, we're going to start with the cosine value, and we're looking for the cosine value of 900. So again, we are looking for the x value at 900 degrees. Well, clearly 900 degrees is not on our unit circle. But what we do have to take into consideration is when we did the coterminal angles. So we need to see where 900 actually falls. So what we're going to do is just unravel the 900 degrees. We know we can subtract 360 degrees, takes me down to 540. We are still not on the unit circle, so I'm going to subtract 360 degrees again. And this brings me to 180 degrees. So this was 900 minus 360 minus 360. And again, where this takes me is 180 degrees. The coterminal angle to 900 degrees is 180 degrees. So 180 degrees on our unit circle is right here. And we are looking for the cosine value of 900 degrees. So what our cosine value will be is the x value at this point, and the x value is -1 equals -1. Now, when we are talking about, on the second example here, sine of -60, well, -60 is a rotation clockwise as opposed to our traditional counterclockwise. So we would normally roll up to the 60 degrees right here. This would put us in this spot. But if we're going -60 degrees, what we end up having is this counterclockwise, which takes us to angle 300 degrees. We are looking for the sine value. Again, this is not the negative sine value. This is just the value of sine, or the sine value of -60 degrees. So we're looking at this value. Sine is our y value. So the y value at this would be -√3 over 2. All right, let's take a look at the third one. Got a lot more going on the third one. We've got -29 over 6 degrees. So a lot of different ways you could potentially do this one. And the way I like to do this, and again, we've got negative rotation. Negative rotation goes this way, so we need to see how many we have. My suggestion to you, we've got the fraction application on our calculator. So we're just going to take our value, -29 over 6, and we are going to add a full rotation. So now we're talking about radians, so we're talking about pi. So what I'm going to do is I'm going to continually add 2 to 29/6 until I get a value that does actually fall on my unit circle. And that value is going to end up being, I guess it could be a negative value. So I'm just typing in my calculator, -29 over 6. And then I add 2 to this amount, and I'm still at -17/6. So I add 2 again, and this takes me to -5/6. And we should have had a pi throughout this, but I treated pi like it was a variable until the end here. So I'm basically adding the pi as we go along. So I'm going to just tack the pi on to the end here. So what we have is cosine, which is the x value of a 56-degree rotation. 5/6 pi rotation. So what I want to do is I want to look at my unit circle and see where I find that 5/6 pi. Well, 5/6 pi is right here. But again, that would be if we rotated in our traditional fashion, the positive way. But we are not rotating in a positive manner to get from here to here. We are rotating in a negative, but we're going to go the same distance. We're just going to go in a negative rotation. So with our negative rotation, we're going to the same spot on our unit circle, which would take us right there. We rotated 150 degrees, we just did it in a negative fashion. So we are sitting right there in the unit circle, and we were looking for the cosine, and the cosine is our x value. So our x value would be negative square root 3 over 2. Next thing we see is 7/3 pi. We can do the same thing here as we did on the last one. You could add 2 until you get a value in this rotation. You can see there's 1/3, there's 2/3, there's 3/3, 4/3, 5/3, 6/3, and that would mean this would be 7/3. If you can develop a pattern inside of your own rotation there, that's a really good move. So that would take us to the 60-degree angle, but what we just showed a second ago will still work. We have 7/3 pi. We have a full rotation, so we're going to subtract this away. So if I do 7/3 minus 2, taking away a full rotation, what I get is 1/3, which I just learned. It is 1/3, and then I go back and tack the pi's on. So we are looking for tangent at 1/3 pi. So when we're talking about tangent of 1/3 pi, if you have your unit circle filled out with the tangent markings, all you need to do is to take your tangent markings. But let's just say that we did not have that value. So I'm going to look for the tangent of 1/3 pi. Well, remember, tangent, like we said earlier, is the sine value, the y value, divided by the cosine value. But we don't want to divide by a fraction, so instead what we're going to do is multiply times the reciprocal. So the 2's are going to cancel here, and we end up with the square root of 3 over 1, so we just have the square root of 3. We're back to the tangent of 225. Well, this one now works out really well. Anytime you have one of the 45-degree angles, you're going to have a value of 1. So here's 225 degrees. There's 225 degrees. So what we end up with is negative square root of 2 over 2 divided by negative square root of 2 over 2, and we know that any number divided by itself is 1. And then the last one is tangent of 13/6. Well, again, if you wanted to count your sixth, you could, but here's the thing you got to recognize. The sixth also reduce. See, here's 1/6, there's 2/6, there's 3/6, 4/6, 5/6, 6, 7, 8, 9, 10, 11, 12, and then 13 is going to take us back to the 30-degree angle. Again, we don't have to do this way. We can take the 13/6 and minus a full rotation, so 13/6 minus 2 is 1/6, and then we just tack our pi right back on. So we are looking for the tangent value of the square of 30 degrees, excuse me. So again, if you have your unit circle, you can just simply do this, but let's just assume that we do not have our unit circle and see how we would go about doing this. So again, I'm not going to set this up as division. I'm going to set this up as multiplication of the reciprocal. So it's the y value divided by square root of 3 over 2. So instead of doing that, I'm going to multiply times the reciprocal. The 2's cancel. So what we end up with is 1 over the square root of 3. And this is that little bump and keep technique that I'm wanting you guys to adopt. We bump the square root of 3 to the numerator, and we keep the radicand, which is 3. Just make a double check on all of these values. Make sure my tangents are the right signs. This is in the first quadrant, so this is positive divided by positive, so that's correct. 225 is negative divided by negative, so that is also a positive number. And then 7/3, if I recall, that takes us to 60 degrees, which is also positive. Always be conscious of your signs. That's usually where people make mistakes when we're talking about tangent.